this this is what we are given. They say if 5 exponent s equal to n, right? So express this thing in terms of n. Now anytime you are giving something like if, or maybe giving, say this is the condition, right? So this one here is a condition, but your starting point should be the second one. So don't start with the if, or maybe giving that, don't start with that one. Your starting point should be the guy here, right? So the next person. So this is what we have here. Now you have to express this guy in such a way that you are going to find this 5 exponent x somewhere in your solution, so that you can easily replace that by what? By n. So the way of doing that is we have 5 exponent s plus 1. That is what we are given from this point. Now what do we know? What do we know according to this? So this is purely exponential, right? So here 25 exponent s plus 1 can be written as 25x multiplied by 25 raised to the power 1. This is the law of indices that says that if these two people are the same, then and they are multiplying, then what are we going to do? We can easily add their exponent. That's what I will use from this point to this guy, right? Okay, now what are we looking for? Now we are looking for the point where we can have 5 exponent s, and then we can easily replace that by what? By our n here, right? So how can we get the 5 exponent s out of this? This is where the s is based, so we can easily get that out of this point. So 25 here can be written as 5 squared, everything multiplied by what? By x, right? So 5 squared is the same as the 25, so everything multiplied here is exactly the 25. 25 raised to the power 1 is the same as the 25, right? Okay, here we can switch these two people here. Remember that law says that these people are multiplied, so the one outside can come in, the one inside can go out, right? So that's what I used to switch this guy here. So I have my 5 exponent s, and then everything raised to the power 2, and then multiply by the 25. So boom, now that we can see the 5 exponent s here, what are they asking us to do? They say we should replace that by what? By n, right? So we are just going to replace that by n. So replacing 5 exponent n from this point by what? By n, and then we are going to have n squared here, right? So n squared, remember there's a 2 outside here. Is that okay? So n squared, and then multiply by what? 25. So 25 multiplied by the n squared will give us 25 for n squared. This is the answer. This is another question with a square root sign. Is it the way of solving this thing is to just apply the definitions, right? Just know what you must use in solving the problem. Now the first step here is to make sure that you are rewriting these numbers here, the big numbers, to suit the smaller one. Because if the numbers are not the same, we cannot apply the law, that definition. Maybe if they are multiplying and then you have the same base, you can add the exponent, and then if they are dividing and then the bases are the same, you can subtract. That is the key there. So you have to rewrite these numbers to suit those laws. So here is the first step. We know that the square root sign here is just 1 on 2, right? So changing the square root sign here means that we are going to raise everything to the power 1 divided by 2. That's the meaning of the square root. Now what about this guy? 8 raised to the power 2. So 8 here, we want to convert this 8 here to suit the 2, because the 2 is the smallest among all, right? So 2 here, so 2 exponent 3 will give us what? 8, right? So the square is still there. So remember, the arrangement is very important. So what about 4? So 4 is just like 2 raised to the power 2. Put that into bracket and maintain the n plus 1. So the same thing applies to the one at the down here. So this is already there. And then what about the 16? 16 can be written as 2 raised to the power 4, right? So that's just the first step. Now your next step here is to make sure that you expand. So we are going to expand the bracket here. So here we have the 3 multiplied by 2 give us what? A 6 here. And then what about this 2 here? Must multiply everything that is outside. So 2 multiplied by n, that's the 2n, and then 2 multiplied by 1, that is also the 2. So the down here is the same as it is. Then you have everything raised to the power what? 1 on 2. So what is the next step? So this is where you can apply that law. Says that if you are multiplying and then the bases are the same, you can just add the exponent. So let's combine these exponents together by addition, right? So 2 raised to the power 6 plus 2n plus 2, and then down here to the same thing, right? So I have the same thing. You see how easy this thing, if you know what we are doing and then how to apply the law step by step. So do your additions here, and then that's how I got a 2n plus 8, and then raise to the power 2n plus 4 plus 4. Everything on what? 1 on 2. Is that okay? So perfect. Now from that point here, what are we going to apply? We are going to apply the law that says that if the bases are the same and then they are dividing, what are you going to do? You just need to subtract. So once you subtract this one, 2n plus 8 by what? 2n plus 4, then you should have something that goes like this. Do your calculation, then arrive at the point where you have 2 raised to the power 4 and then everything raised to the power 1 and 2, and then have your final answer to be 4. If you have any question, just comment below. Your starting point of solving this question. So this is the question, right? So you want to solve this thing. Now the starting point here, since this is exponential, you have to make sure that you bring these guys down, right? So the way of bringing these guys down is to find a number that we can raise into certain power. So here 16 here can be written as 4 raised to the power 2, right? And then 27 here can also be written as 3 raised to the power 3, and then 8 here can be written as 2 raised to the power 3. Now the trick here is that you have to make sure that you are going for a number, the smaller number, in such a way that there is no any number below that, right? So you can see that here, from here we cannot have, let's say, 3 raised to a certain power that can give us a 16, right? So we are going for the last born, right? So the last baby here. Is that okay? So here the same thing. Here we have 27, so 3 raised to the power 3 will give us 27. Now remember, if you go for 2, you cannot get any number that you raise to the power will give us 27, right? So that's what I mean by going for the last number. For sure, you have the exponent here, so this being raised to the power -1 on 2, there, so 2 on 3. Is that okay? So that should be the first step from this point. Now moving on, here you have to apply some of the simple law of indices. So here you can see that here we have 1 on 4 raised to the power 2 can be written as 4 raised to the power -2, right? So if you have something that goes like this, I can rewrite this one to be 2 raised to the power -4. Is that okay? So, and the vice versa, right? So where it's needed depends on what you are looking for. So here we are going to simplify. That is why we are bringing everything down. Now why? So here tends to be 4 raised to the power -2, right? So this guy here tends to be 4 raised to the power negative. Remember, there's another power outside here, that is -1 on 2, right? So here the second part, from the second part here, is that here we can easily bring, you see, these people are carrying the same thing. So what I mean by the same thing, this is being raised to the power 3, and then this also raised to the power 3, right? Okay, perfect. So for that reason, they can go outside, right? So if you have something like this, let's say 1 on 2, 1 raised to the power 2, and then 2 raised to the power 2, I can rewrite this thing to be 1 over 2 everything raised to the power 2, right? Because I'm seeing the same thing here, the same thing here. So that is how we brought the 3 outside from this point, right? Remember, there's a 2 on 3 here already, so these two people are multiplied. So performing the operation from this point, you have 4 raised to the power -2 multiplied by 1 -1 on 2, and then plus 2 on 3 everything raised to the power 2, right? The 2 is coming from this one. You can see that these people, if you are multiplying, if you perform this operation here, you should have 2, right? So I have 3 multiplied by 2 on 3, they cancel out, right? So these people cancel, so you are left with just 2, right? Okay, perfect. So once you are moving from this point, you see that your work done is very, very easy here. So the same applies to these people. So these and these people here are going to cancel, so you have 1, right? So -2 multiplied by -1, that should be 2. So 2 on 2 is just equal to 1, right? Okay, so that's how you had a 4 here for the second part here. Remember, the 2 here raised to the power 2, the 2 is affecting anything that is inside the bracket here. So 2 square will give us 4, and then 3 square will also give us 9. So performing this thing here, you should find your LCM. That's the least common multiple, because they are adding. This is just a fraction, so they are adding. So solving this one, have 40 on 9, and then into a mixed fraction. So this is an improper fraction, right? So the top one is bigger than the down one. Okay, so here we have 4 whole number 4 on 9 to be our final answer. We are giving 2 to be equal to 2 t here, right? So t to be equal to 2 exponent -2, and then we want to find 2 exponent s plus 1 in terms of t. So what it means is that your final answer should involve t, right? Now this is what you are giving. You are giving this. Giving this one means that you are going to start with the exactly what you are looking for. So in this case, you have 2 exponent s plus 1, right? So here with some ideas of indices, right? So the benefits of indices test mean that 2 exponent x plus 1 can be written as 2 exponent x and then multiply by 2 raised to the power 1, right? So you know the law of the index that says that if these two people are multiplying and then they are being raised to a certain power, these people must be the same. Once they are the same, you can add the exponent. So that's what I use to convert this guy to this point, right? But the key here is that we must see somewhere to be a negative 2 raised to the power negative s, so that we can easily replace that by what? By the t, right? So that is the point. So here you can see that this is just already in the basic form, so you cannot do anything to this guy again. So what will happen here is that what about if you have t to be equal to that's the 2 exponent negative 2, right? So what will happen if I rewrite this guy to be, this guy can be written as 1 or 2 raised to the power s? Do you agree with this? Right, so from the previous example, so here we have t to be equal to that to be that. So solving for the 2 exponent s, right? So because we have 2 exponent x here, so that I can easily replace this guy here by what I'm going to get it. So here should be 2 exponent st, and that should be equal to 1, and then dividing both sides by t, right? So divide here by t and then divide here by t. This one cancel out. We have 2s to be equal to 1 on t. Is that okay? So with this 1 on t, I can see the 2x here and then 2x here, right? So 2x here, 2s there. I can easily replace that because there's a 2x here and then there's a 2x here. So what I'm going to do here is that because I have from this point that 2 exponent s, that is equal to 1 on t, so just replace that with this guy here. So we have what? 1 on t from here and then multiply by what? 2 exponent of 1, right? Which is the same as what? 2. So this is going to be 2 over t, right? So the top one multiply the top and the down one, we have the same answer. So this should be what your final answer as you required, right? So this is very simple, straightforward.